Up to number 4 now, and this is actually more of a climatology thing. And it's a combination to one, the lack of thunderstorms, especially severe thunderstorms we had during the year, and also the below normal precipitation across much of the area. Start by taking a look at severe thunderstorm warnings. We couldn't count the total number of thunderstorms, really hard to find that information. But this is the number of severe thunderstorm warnings we've issued pretty much over the past decade or so. You see a couple of years really stick out. 2018, 2019 really stick out. Very active years for convective weather that year. Only 50 back in 2017. We did have a big outbreak of severe weather that year though. Also 2013 sticking out with 80. Now as far as the least amount, see it's the second lowest of that whole time. Lowest was 2012, only 25 that year. And the average over this period is 64, so we're about 30% below normal on that. Now overall rain and snow that we got, this is really impressive. Take a look at this. The only place that's above average is Lake Yellowstone, fairly active there. These are official climate sites. You can see anywhere from, say, only about 60% of normal all the way down to Big Piney. That's the lowest, only 35% of normal there. Only been around 2 inches of precipitation there so far this year. So many areas well below normal. So you're asking, why did this happen? A lot of reasons, but I think the 3 main ones are, number 1, the main jet stream flow is usually where the storms track, and where it tracks usually you get more precipitation, more rain and snow. It's actually mainly away from the state, especially during the summer months, therefore less thunderstorms and less rain, as well as snow in the winter. Now number 2, we have more ridging over the area. Now think of a ridge basically, when you look at an upper air chart, basically it's a bulge over the area. And what it does is basically help stabilize the atmosphere. Think of it as just more bricks being stacked in the atmosphere. You need lift to get precipitation. So the more bricks, the less lift you get, and therefore the less rain. And finally, you have a lack of low-level moisture around the area. A lot of that, the ridge actually shut a lot of that off. A lot of the Gulf moisture tries to wrap in here, especially during monsoon season. And that actually leads to kind of a chain reaction where you have less low-level moisture, also less soil moisture to evaporate and produce cumulus clouds as well as thunderstorms, and therefore a lot less rain across the area. Well, that's number 4. Well, number 3 tomorrow.